In every age, humans have wanted to know an answer to a basic question. How did the world begin? What did it look like then? And who made it? Of course, peoples living in different societies with different religions have had very different answers. The Greeks, 2,500 years ago, said it was the great god Zeus living on top of Mount Olympus, hurling thunderbolts at the earth. The Hindus have their own version of creation that is written in the Ramayana and the Mahabharata. And if one is to believe the great Archbishop Osher, the world began on Sunday, the 23rd of October, 4004 BC. Of course, many people in the United States still believe that. And then the question is, what holds up the earth? One view is that it is on the back of a giant elephant. But what holds up the elephant? A turtle. What holds up that turtle? Another turtle. And it's turtles all the way down. Modern science also gives us a picture, a view of how it all began. But this view is not to be put at the same level as the others that I've just put before you, because it comes supported with proof, with evidence. Today, all scientists, and I mean the real ones, believe that the Big Bang theory is just about as solid as the heliocentric theory, which says that the sun is at the center and the earth and the planets go around that. But why do they believe this? Because there are three important pieces of evidence. Firstly, we see the universe expanding outwards. And this story goes back to the 1920s when the American astronomer Edwin Hubble was looking at the sky with his telescope, and he had also with him a spectroscope that allowed him to see how fast the galaxies were moving. What Hubble saw was very interesting. He noticed that the further away a galaxy is from us, the faster it is moving. And so this brings to mind the picture of a bomb explosion where you have a core and there's a shell around that core. When the bomb goes off, the fragments of the surrounding shell move away the furthest because they're moving away the fastest. Imagine that you were to take a video of this expanding universe or this expanding bomb. As time goes on, the galaxies move away further and further, but now suppose you were to run that video backwards. As you run it backwards, all the galaxies come together and they meet at one single point. That's the center of the universe. And it would take you 13.7 billion years to run that video backwards. That's the first proof. The second has to do with what the universe is made up of, the matter that constitutes it. Now you'll say, how do we know what there is in the universe? Because we can't go out to some distant part of the universe over there and catch a piece of matter and bring it back and study it here on Earth. Yes, we can't do that, but there's something that reaches us from there here on Earth, and that's light. That light is emitted by different atoms, and we can recognize which atoms are emitting that light by looking at the color, or what we call the spectrum of the light that reaches us. And so in this manner, we can actually very accurately determine whether there is hydrogen there or helium or lithium, beryllium, boron, etc. Now, in 1948, George Gamow and his student Alpher said, if this idea of the Big Bang is correct, then we ought to be able to predict how much hydrogen and lithium and beryllium and boron and so forth there are in the universe. The way they did it is this. They said at the beginning, it was much too hot to have atoms because they would simply melt away. Instead, we would have neutrons and protons, and neutrons and protons normally stick to each other, but when it's too hot, they can't do that. It's only when the universe has cooled, and that would take 3 minutes after the Big Bang. It's at that time that the neutrons and protons would be able to stick together, form deuterons, and then the deuterons would be able to hit other deuterons and in this manner make helium. So, Gamow and Alpher made the prediction, and mind you, in 1948, that the universe today should have something like 75% hydrogen, 24% helium, and then 1% of all the other elements like lithium, beryllium, boron, and so forth. The astronomers went out and looked for it, and they found they were just absolutely on the dot. That gives us a lot of confidence in the Big Bang Theory, and especially today with much better equipment, instruments, satellites, and so forth, we know that the composition of the universe is very much what the Big Bang Theory predicts it to be. This was relatively easily explained, but the third reason that I'm going to give you is not so easily done. Still, let me try. Something like 270,000 years after the Big Bang, there was a big change that happened in the universe. Earlier on, it had not been possible to have atoms because the universe was much too hot then. But at this time, 270,000 years later, there was now the possibility of making atoms. Now the light, the photons, would be free to travel. And so today, what we can observe is the transition that happened at 270,000 years after the Big Bang, and see those very photons. This was something that was observed in 1965 by two American scientists, Penzias and Wilson. Penzias and Wilson were not cosmologists. They were not looking for evidence of the Big Bang. Instead, they were scientists who wanted to understand how to communicate with satellites, and they had developed this very sensitive piece of equipment which was giving a very strange sound like sss. First they thought it was just the equipment being too hot, so they cooled it down and they cooled it down. Didn't work. Then they thought it was pigeon droppings. That turned out not to be the case. And so finally colleagues at Princeton University told them, maybe you're seeing what George Gamow had predicted way back in 1948 or 49. That is to say, there should be something left over from the Big Bang that you're actually seeing. And so that's the third piece of evidence that we have before us. To conclude, we now feel that the Big Bang is on very solid footing. The universe is expanding. We see that. We see the distribution of elements in the universe being exactly that which is predicted within errors. And the third is this cosmic microwave background radiation. So the Big Bang is on solid footing, but there are questions that I'm sure that must have occurred to you. I said, all the galaxies are running away from us, but why do we matter? I mean, why should they run away from us? Suppose there's somebody at the other end of the galaxy. Would they be running away from him as well? If so, how very strange. How is it that he can be the center of the universe and we be the center as well? Actually, there is an answer to this, but you'll have to wait for the next episode.